The Europa-Jupiter System mission, Laplace, was a proposed joint NASA-ESA unmanned space mission slated to launch around 2020 for the in-depth exploration of Jupiter's moon with a focus on Europa, Ganymede, and Jupiter's magnetosphere. The mission would comprise at least two independent elements: NASA's Jupiter Europa Orbiter, or JEO, and ESA's Jupiter Ganymede Orbiter, or JGO, to perform coordinated studies of the Jovian system. Although, in April 2011, ESA stated that it seemed unlikely that a joint US-Europe mission will happen in the early 2020s given NASA's budget, so the European Space Agency is investigating the possibility of proceeding with a European-led mission. The ESA-led mission is called the Jupiter Icy Moon Explorer, or JUICE, and will be based on the JGO, or the Jupiter Ganymede Orbiter design. The Jupiter Icy Moon Explorer would perform detailed investigations on Ganymede's moon as a planetary body and evaluate its potential habitat. Investigations of Europa and Callisto would complete a comparative picture of these Galilean moons. The three moons are believed to harbor internal liquid water oceans, so are essential to understanding the habitability of the icy worlds. The main science objectives for Ganymede, and to a lesser extent for Callisto, are characterization of the ocean layers and detection of putative subsurface water reservoirs, topographical, geological, and compositional mapping of the surface, study of the physical properties of the icy crusts, characterizations of the internal mass distribution, dynamics, and evolution of the interiors, investigation of the exosphere, and study of Ganymede's intrinsic magnetic field and its interactions with the Jovian magnetosphere. Now for Europa, the focus is on the chemistry essential to life, including organic molecules, and on understanding the formation of surface features and the composition of non-water ice material. Furthermore, JUICE provide the first subsurface sounding of the moon, including the first determination of the minimal thickness of the icy crust over the most recently active regions. The main spacecraft design drivers are related to the large distance to the Sun, the use of solar power generation, and Jupiter's harsh radiation environment. The orbit insertion at Jupiter and Ganymede, and the large number of flyby maneuvers, more than 25 gravity assists and 2 Europa flybys, requires the spacecraft to carry about 3,000 kilograms, or 6,600 pounds, of chemical propellant. Thank you for joining me. This is Planetary Television.